So, what we're going to see today is basically do drop ledges. Of course, we're going to recycle one of the animations we have, okay? And I've checked, and even in Assassin's Creed and other games, they don't really have something special for a case like this. So, this is one thing we're going to see. The other thing we're going to see is, let me go over there, is a little bit of fix and a few more bug fixes. But most importantly is when, if you remember, when we're going from brace position to hanging, okay, the in between was looking way more awkward. So what we're going to do is fix the hips position. Instead of going like this, where the target position in between those 2 points is exactly in the middle and a little bit back. If the target point is a different point type, okay, in this case it's hanging, then we're going to pretty much work with changing, having the correct position for the hips. We're going to switch a little bit what we're doing with the curves for when jumping, and that's why and we're going to do that basically because the previous way we had it, if we had a climb system that was rotated abnormally from the local the local axis or the world axis basically, okay, if it was like this, then things started to break apart, but you will see that it's now fixed. So let's get to the code because we have a lot to cover. Before we go to the code, let's see the only new animation we're going to use on Cider Animator on our climb. Okay, we're going to add a drop state drop ledge. I just recycle the jump up, okay, the jump up animation, and of course do not forget to add enable root movement and the timer what you see fit. And over here just a transition with HasX time going to the ledge idle together. Okay, let's go to the code. So the first thing we're going to actually see is when we are updating, when we are moving linearly and we are updating our positions, okay, when we are initializing the transition, basically our lerp, we're going to come over here and over here, okay, and what we're going to see, we're going to have a bool if they are different types. So if the target point is not equal with the point type of our current point, we're creating a new position which is basically going a little bit down, okay. Now if there are different types and the current point is actually hanging, then we are disabling the different types. So this will only work when going from braced to hanging. The opposite way, we do not want this because it didn't look that great, okay. So we come over here, and the same way we had before the two-step transition, we're going to say, okay, if there's different type and two-step, then the target position we also add on the target position the down. If any one of these is false, it's going to come and say if the two-step is true, then it's going to go back and add the previous transition. Okay, this is a simple way, as you can see, that handles that problem. Let's see the other thing we have. Okay, now we're ready to basically do the drop ledge. the first thing we need to know, and basically how this thing works, is if we are moving towards an edge, the first thing you need to stop doing, of course, is moving. Okay, so when I move towards an edge, when there is an edge over here, and of course there's a few bugs, okay, then the character will actually stop moving. If I hold shift while moving towards the edge, then it's going to ignore that logic and he's just continuing to fall. If I'm going to an edge, or if I am at an edge like this and press space, what it does is he looks if there is a climb tree, or you know, a climb grid over here, if there is one, and if there is, it finds the closest point and it comes, assigns that as a target, and we're going to add the dismount groove and all that. Now, the first thing we need to do is we need to go on a state manager, and we're going to add a new boolean is ground forward. And let's see where all this is useful. So, character on edge, states, and states ground forward. Inside our handle movement, inside its tick or its update, of course this runs to the update, we're going to have a new boolean which is ground. It's going to be overwritten by is ground towards direction. This is a new function we're going to write, and it takes a direction. The direction we want is basically the direction we want to move. You can assign this into the transfers forward. Okay, you should probably do checks and see what works best for you. Okay, I find it that this works just fine. If it doesn't, just switch this. Okay, and we have this basically updates the is ground forward inside the states. This function, let me remove the bookmark. What it does is it comes over here. Okay, it will turn a boolean. We find the origin, which is the direction, and we add an offset to it. We multiply that with the offset, the origin with the offset. Okay, and we add a little bit of up, so it's about hips level, or knee level, I think. Yeah, probably knee level. Okay, and we also add our own transfer position to the origin. So we do a raycast, which is an encapsulated raycast. We pass the origin, we pass the direction. Okay, if it hits something, then it's going to return true, and the distance is going to return is, of course, 1. Okay, and if it finds something forward, it's going to return value. It's going to assign that as the return value. But if we are holding left shift, then it's always going to return true. And over here you can be even more, careful and do, I think, layers, or we might not even have them. Yeah, this probably might need to add a layer mask to basically ignore its own controller, but you will see that it's about over here, so there's no way he can hit his own controller. Okay, so even leaving it like this won't give you exactly a problem. Okay, so is ground towards direction. So if we are on the ground and there's ground forward, we are doing what we were doing before. If not, then remove the velocity and set it to vector 3.0. Okay, this is the simplest way we can do it. And of course you can make him play different animation to indicate that he's at the edge. Now, we've seen this. Let's see why I have this. Yeah, when we are ticking inside the handle animation, when there is the update, instead of just assigning the float movement to the animator, whatever animation value we have over here, if we do not have ground forward, then we're just simply going to smooth, set the movement parameter to 0. Okay, simple enough. As you can see, up till now we're just adding a few lines and nothing else. And let's see, let's go into our climb behavior. We're going to add a few new stuff, as you can see. Speed for the droplets, of course. 0 to 1 is a new animation curve which does what it says. You get it over here, and it's basically this. Just as you can see, before we actually go on time near 1, or basically when you're going near 1, then only then you go and raise the value to be at 1. Okay, and this is useful for, you know, assigning the weights and all that. Now, I've changed the whole curves logic. If you remember, we have everything over here, we have a lot of curves. Let me delete this. And instead of getting the curves from over here and assign them, I've just taken them from inside our curves holder, and I just hold the current curve since that's what we need. Curves holder, so, and what we're going to do is actually go onto our enum, and instead of having horizontal and vertical, we're going to separate them with up, down, left, right, dismount, mount, and drop ledge. So what this gives us is we can come in here and say inside our prefab, which is inside climbing and resources, okay, we have our curves holder, and we now have something that looks like this. So if I have an animation that I want to tweak, let's say jumping left wasn't that good, or the movement wasn't that good, okay, I can come inside this the correct curve and basically change the handles and tweak only this curve. So if I jump from to the right, it's going to use its own curve. If I'm jumping to the left, it's going to use its own curve and all that. Okay, and that goes for every direction and for every motion. So what you need to also do is populate this list. Okay, add the enum, add the curve, and you're all set. Since we have this script with this function which returns us a curve type, we can select which curve we want just by the enum. Okay, it's just a simple way. The only problem, quote unquote, is if you have a lot of curves. Okay, but I think it's way easier than having to rotate stuff around and making sure they are in the correct rotation. The way I've done it now is, if I place the curve holder with the correct rotation, which is usually looking where the point is looking, then as you can see, I do not have to worry about curves and their rotation and all that. The dismount curve, and of course, you know, the second point doesn't really matter where it is, since we are fixing it with code. And the drop ledge curve is something like this. Okay, look where the forward is, and we basically just need this motion. It doesn't have to be, this isn't even directly below the other point. You just need this, I think this type of curve, or the motion like this works just fine. Okay, that is your curves holder, or your new curves holder. Let's go back into our climb behavior. And now that we've seen everything we need to set, we can come over here and we have a new function which we're going to call character on edge, and we're going to be using this inside the fixed update. And if we are climbing, if we are not climbing, not if we are climbing, if we are climbing we would not need to drop on a ledge, of course. If we are not climbing, okay, we're also going to be looking towards where what we said. So the first raycast is basically doing, and I think if I leave it like this, you will understand it better. Let's go close to our character. Okay, see, you see the raycast you see over here. Of course, he's going like that because he rotates with the camera. We're going to see how to fix this. Okay, this is the raycast. It does a raycast forward, so it doesn't find anything over here, and you can see the debug.draw ray that it hits, or not that it hits, that it looks towards there. Okay, of course I know it hits something over here, and if you press space, you can see where it placed the drop ledge curve. Okay, and as I said, the final point, the final destination doesn't really matter. So, character on edge, let's see this. If there is no ground forward, the origin will be transfer position. We add forward to our own transfer position, and we want a point beneath us, so we add a vector 3, a third of the vector 3 dot up, so which is a third of 1 point. Direction will be towards the origin, towards our root basically, but we want it to be dimensional, so we take care of the Y. We do a raycast hit. The layer mask is the layer mask we're going to ignore. Okay, we bit shift the layer of our own game object, and also the ignore layer. The ignore layer is mostly just to be safe. I don't think I'm using it anymore in any of the projects I do, so yeah, just keep it like this. And of course we need to do the opposite, because we want to ignore these two layers. The debug draw array, we do a raycast, origin, direction, out hit. Okay, distance of 1, I think distance of 1 is enough, and we pass the layer mask. If what we hit has a component in the parent that is manager, we assign the manager, so we don't have to use all this every time. The closest point, we use what we have inside the manager, which is return closest to our own transfer position. We find the distance to point, okay, between our own transfer point and our closest point. And if the distance point is lower than 5, if it's higher than 5, or you can play with the value, of course. If it's higher, then that means it's just far away, so you probably shouldn't even be hitting that, so that's probably a bug. Okay, and if you're pressing space, then we're going to assign the current manager, which is what we find over here. Target point will be, of course, the closest point. Target position will be closest point, transfer position. The current point will be the closest point. Okay, climbing is true, lock input true, drop on a ledge true, and this is a new variable. Okay, bool, drop on a ledge. And we just manually go and disable the state manager, the controller from the state manager. Okay, you can of course do this a little bit more elegantly, and we can say wait to start climb. So this will make your character find a climb position that is below him. Now we have handle climbing. Let me see why I have this. Yeah, another bug fix is inside the manager. This is a parenthesis from what we're seeing, but it's needed. And why it's needed is when we are returning the closest. Previously, we're just taking all the we were just looking inside all of the points. Of course, that led to a problem that when you were getting the closest point from over here, okay, the closest point that will be the actual dismount points we have over here, which of course that is a problem. And okay, so the closest point will have been one of these that goes over here. Okay, so basically when you're dropping on that ledge, it will assign this as the closest point. Of course, obviously this is an error because these aren't even part of the main climb tree. So what we need to do is we need to add a for loop, get all our points. We need to find where we're looking for the distance, and if the current point we're looking to is a dismount point, then we're only going to skip it. Okay, we're not going to compare it with the minimal distance. Okay, so that will fix the bug that comes out from the code we've seen previously. Let's see. Yeah, this is a little bit of more bug fixing, which what does is find the dismount candidates. It's going to come and say it's going to assign dismount points that it creates as dismount points, and what it's also going to do is it's going to create the new prefabs, and instead of just creating and let me think. Yeah, basically we had, if you were going manually and instead of assigning the instead of assigning this dismount point, you were going and saying directly to a point dismount point, that will lead into a problem that the automatic generation will not include that point. So you basically would have a point that you couldn't dismount. So what we are doing over here is say that okay, we find the prefab, we get all our handle points, we have a list of candidates, we go from all our handle points and add the dismount point and see if it's a dismount point, we add it into our to our handle points, and this should probably be and if it is, then it comes over here, it creates all the points for the candidates. Okay, it creates all the dismount points, and it's going to create the neighbor connections, and I actually do not see what I did. Wait a second. And yeah, this should actually need to be changed a little bit, and yeah, so what we need to do to change, let's say it, is let's do an array of a point, and let's take individually the points, or let's call them something like this. Okay, and we're going to say get components is children, come on, point, and we should do another for loop and see those mount points, those length if this point I not this mount point, and if candidates do not contain of course we want the opposite. And then come and add the dismount point, and this will catch up any rogue dismount points. Okay, I got confused because I actually didn't fix that for the dismount points. I fixed that for the hanging points. Okay, so what I was doing, okay, the same thing we were doing before, get all position 100 points. If it was a hanging point, then it adds it into the candidates, and after that we get all points. Okay, and we do the same. If it was a hanging point, then we add it to the candidates and all that. Now do not get too attached to the 100-point connections that automatically creates the connections and all that, because I actually thought of a way to circumvent all that. So yeah, we're going to do it way later in a video though. Anyway, forget about that now. Just know that this is going to change, or some of these are going to change, not all of them. And yeah, this is another bug. You need to add this to avoid another bug, which was the same if you had a hanging point that you had assigned. Instead of going and ticking this, you went into an individual point and assigned the point type. Okay, it will ignore it ignore the hanging, the fixing of the heaps, so if that will look wrong, then you just need to come over here and assign this. Okay, let's go back to our climb behavior now. We've seen almost everything. Handle mount. Okay, we know we do not have any ground forward. We were character on edge. Okay, and the player has pressed space. It goes into fixed update. The player has pressed space. It comes over here climbing. It says wait to start climb because we have initialized that. Init climbing and handle the mounting curve. Init climbing. Then we will come and say if, and I think it's basically going to say the same for the most part. Init climb. If the AK is not null, then assign it. Current connection direct. Target state on point. Okay, this stays the same. However, handle mount. When we are initializing the transition, we have a new system for our curves. So the current curve will be set if we are dropping on a ledge, then it's going to go to the curves holder and say return curve type drop ledge. Okay, it's going to return you the curve that you made for dropping on a ledge. Otherwise, it's going to return you the previous curve, which was the curve type mount. Then over here, if you're dropping on a ledge, I manually set this to play and crossfade basically on the drop ledge animation with just 0.4. You can set this to something else. And I just reset the drop on ledge. Okay, we are on our climb grid now. There's no need to have this open. So instead of worrying about this later, we can simply come over here and make it drop on LEDs to be false. Now, something else we need to basically do, handle wait all. Okay, we're passing RT and we pass our mount, the mount curve, handle wait all. We pass the previous curve we were using. However, this isn't necessarily has to do with dropping on LEDs, but we're using this too. Handle wait all. Okay, float. We were assigning, we were evaluating the float, the curve based on the t. Okay, and we were assigning that to the AK. Now we're going to see if our current point is current point type hanging and the target point is point type of braced. Then it's going to reevaluate a new curve, which in our case that will be 0 to 1, because we basically want to start, and we are starting with no weight on our AK, and we only want to open it when we're very close to the edge of where we're reaching our edge, basically. Okay, so it's going to assign this like this, basically. So, and it's only going to, the special case we want this to be assigned is when our current point is hanging and we're going into a point type that is braced. And we use influence weight left and right foot, and we manually override the above curve. As far as the dropping on the LEDs is concerned, then the regular animation curve we are using is going to work just fine. Okay, the amount curve works exactly as expected. And now basically we're only going to see bug fixes. So inside update connection transition by type, I had this the direction. I have no clue why I had the direction. I was passing the direction over here. So this is wrong. Let's delete this. Instead of passing the direction, I simply change it. Well, we have to change it now because we have changed the whole system of our, how we move with our curves. So instead of passing the direction, I'm passing the input direction instead of passing the direction you see we have over here. Okay. Once this, let's see the other stuff. And this is, this is basically where we need to change our curves now and our curve behavior. So on update direct variables, previously we had a lot of if statements and all that just to find the correct curve. Now, to rotate the curve correctly, basically. Now we have separate curves, so we're going to encapsulate that into a single function, which we're going to call find curve by input, and we will passing the vertical bool if we're going vertical or horizontal, basically, and we're going to also pass the input direction. We're going to, after we find our curve, we're going to assign the correct rotation, and everything else is correct the way we had it before. So find curve by input, bool vertical, input direction. The return value will start as null. If we are not moving vertical, then that means we're moving horizontal, and if the x is higher than 0, that means we're moving to the right. Then the curve we want to use is the return curve type to the right. Otherwise, the left. If we are moving vertical, then it's either up if the y is over 0, or either down. And this will return you, and it's going to assign the current curve. And I think we're pretty much done. The only thing left is we had over here the previous where we were instantiating the curve holder and we were assigning them into the variables we had here. This is redundant now, I guess. So basically what this does right now, this is just going to find you the prefab for the curve holder and instantiate it. Okay, that's basically it. And one last thing is with the climb key, what we had before, just trying to find a different position in front of the target point and all that, and making it look towards the shoulder and all that. Yeah, all that was useless. Exactly when you were rotating into a non-hard-coded direction, so when you basically weren't looking towards a wall position that was either 0, 90 degrees, 180 degrees, and 360, which will be 0 again. Okay, that was useless, so I changed that. So basically just the last bug fix we need to check. We start with the offset of 0, we add a transform forward, we add a little bit of up multiplied by basically 2.2, and the way I'm using vector 3.0, if I haven't covered this before, is because if you're doing vector 3 something and you're doing new vector 3, okay, you've seen this done a million times before, even I have done this a lot before. If you have this inside the regular update, inside your regular update and doing this every frame, then go check your profiler, because you are creating a lot more garbage than you need to. Okay, so instead of doing that, we just start with a 0 vector and assign any values we want to add manually. So transfer forward, transfer up, and of course our own transfer position. We find our target rotation, which still goes to the direction towards our shoulder, and we apply that as the look rotation, and this will fix any problems you had. Okay, you see that this is clamped pretty much. A climb system like this, or a climb grid like this, is pretty much clamped into wall directions. It's looking directly towards the wall directions, but in a case like this, everything breaks down, and with the little bug fixes we added and the way we are doing the curves now, then everything will work just fine. Okay, and it's actually coming along way better than I expected. So we've covered everything for this part. You know what to do. If you don't know already, then you should hit subscribe, you should hit like, and also if you like what we're doing, then you should also consider supporting me. The ways you can support me is either through Patreon or by grabbing a project or two, including this one from Gumroad. So I'll see you next time.